were arguing about is coding a language or not.
So I walked up to my local newsagent, Lennon's, and I used to get a copy, I think every month probably, of Crash magazine or ZX Spectrum magazine. So what I would do is, hour after hour, I would type in these printed pages of code onto my ZX Spectrum.
You said that coding is an art.
The way I think of it is that I believe that whenever you go to learn a new skill, computer coding, painting, playing your guitar, you have to start from somewhere. Therefore, you have to begin to learn the basics.
With the access of AI and the ability of what AI can do, how can that be introduced to schools and students?
I'm not in any way denigrating teachers. I think they do a really hard job, an increasingly hard job. But
I want to understand a more fundamental way of the more fundamental understanding of the modern tech that goes to coding. And I know that you assume coding in a very different way than what outside non-tech people like me would think coding as. And just before going to that, because I remember me and one of my friend who was a master student in computer science, we were talking about coding, and we were arguing about is coding a language or not. And then we went on to discuss is math a language or not for 5 hours.
Yeah.
So what do you think coding is, and how should we look at it when we want to think in terms of understanding what it lead to in terms of modern tech?
wow, starting with the easy questions then, hey? Diving in at the deep end. Maybe it might help to try to begin to give you my thoughts on that, which are not necessarily, the right thoughts, it's my thoughts. But to give you a little bit of where I come from, which kind of informs my views on these things. So I've worked in, I've been playing with computers since I was about 8 or 10. I'm a self-described geek, nerd. I like tapping away on a computer. Luckily, I get paid to do it, but I would still be doing it for fun, if I didn't get paid. So I'm one of those. And so I taught myself to code on my ZX Spectrum by, because believe it or not, in the last century, as the kids call it, I believe, we didn't have the internet. Didn't really even have didn't have dial-up, never mind broadband. Didn't have Google, didn't have search engines, didn't have places to go to cut and paste snippets of code, none of that. So I walked up to my local newsagent, Brennan's, and I used to get a copy, I think every month probably, of Crash magazine or ZX Spectrum magazine, and pore over all the interesting new stuff, because that was the speed information traveled, every month or so. How things have changed. And they would have a lot of printed listings. The language was BASIC predominantly then. I don't mean basic as in simple, I mean basic as in basic. And so what I would do is, hour after hour, I would type in these printed pages of code onto my ZX Spectrum, which if anybody who's used one of these, they will understand that is not the easiest of things to do with a rubber keyboard and all the rest of it. And, if you lost power, you would lose all of your work, it would all be gone in an instant, which happened. And often the code that was printed in the magazines had typos and problems. These were bugs. And so as a part of all of this process, trying to get a game from a magazine to work for me, I learned to debug code and make it work and figure out what it was doing. So that was essentially how I got started. And I suppose I've been doing the same thing ever since, really, for the past, 40 odd years. So, and for me, as I'm sure for many people, there's been just an incredible amount of change over that period of time. And I do quite like change. So, I very much a fan of maths myself. I studied maths at A-level, maths and physics, that kind of thing. As I remember, we didn't have computer science as a course back then. because if you did computers, you were kind of a weirdo, and this is pre-console days, it's pre-FIFA days, so people thought you were quite odd if you liked computers. So again, that's all changed. And then I went to university, and I didn't think that I would be able to just sort of sit and do maths in a room all the time. And I don't think we probably did have computer science courses at that time. But I went to study engineering. And I studied engineering, electrical, information, and sciences tripos, which was a bit of everything. And I sort of went off to specialize in some computing. I'm more on the software side of things than the hardware side of things, but our business does create hardware devices from scratch. We design the PCBs, manufacture these things, integrate software on them, connect them to the internet. That's fundamentally what I spend my days doing today. It's how we earn some income to pay the bills. And I feel, when I think about myself, I think of myself as an engineer, not a computer scientist. So I think of myself, others may disagree, but I think of myself as a problem solver. Most of my daily life and how we deliver value to our customers is solving their problems in the technical space, in the connected devices space, mostly. And so I'm less interested in the particulars of the correctness of, oh, this language is great, or oh my word, isn't C++ this fantastic thing? Doesn't the Zephyr RTOS abstract operating systems in a wonderful way? No, I care about getting the job done, and I care about getting it done on time and in budget, and I care about delivering something that's reliable and fit for purpose to the client. Because particularly with what I do, which is embedded systems, or there are so many names over the years. We've had embedded systems, pervasive devices, connected devices, machine to machine, and we're currently talking about IoT, or the Internet of Things, and the fourth industrial revolution. And so we're typically delivering large numbers of thousands and tens of thousands of little black box devices into different marketplaces, and they might go all over the world. And if they stop working, and they happen to be on an oil rig or installed into a bus or in a garage as an alarm system or talking to some space satellites, then it becomes really difficult to fix that problem. So a critical part that I focus on as an embedded engineer is making sure that what we do keeps working over what can be 5, 10, maybe 15-year lifetime, without people necessarily interacting with it physically, turn it off, turn it on again. So that's quite challenging, if I say so myself. And over many, many years, I've been party to numbers of flame wars, we used to call them, about which language is better than which other language, which operating system is better, which computer platform is better, Amiga versus Atari ST was a big one back in the day. C++, we all love to discuss the merits or other of that, and on it goes. And I do much less of that nowadays because I don't have the time or the energy, to be honest. What I care about deeply is knowing about great tooling that enables me and my team and the people I work with to do a great job in a cost-effective manner and deliver a great solution. And so I use lots of different tools depending on what we need to do to try to achieve that aim. I talked a bit at length there, I suppose. So do you want to come back on that? Or?
Yeah, I mean, you said that you think coding is like, you said that coding is an art.
I would say so. I recognize that could sound quite odd, but the way I think of it is that I believe that whenever you go to learn a new skill, computer coding, painting, playing a guitar, you name it, you have to start from somewhere. And therefore you have to begin to learn the basics. Presumably, I don't paint, but presumably how to use different brushes and different paints and different kinds of paints, different styles and different approaches, and how you construct the thing that you're creating, how you do it. And I suspect that, and you know, chords on the guitar and practicing your chords or playing on the piano, and there is a very mechanistic, a very mechanical process that you have to go through, and often for a long time, to get those basics and to know how to do the thing you're trying to do. And while you're trying to do that, I suspect again that you're not really free to do lots of experimentation, because you're still learning, you know, what's available to you, how you can approach things. And then I think you get to a point where you have this toolbox of sets of skills within this discipline that you care about working on. And then you can sort of let fly and create and pull in this knowledge that you have to make something, to make a wonderful painting, or, you know, play a wonderful tune, or whatever it might be. And I think we would agree that that is art. And for me, it's the same with coding. You know, a lot of what is, I think, talked about in the public domain in terms of the educative process, so courses in schools and universities and training to go and get a job, is very much about, okay, we're going to teach you how to program in Python or learn this language, or, you know, blah, blah, blah. And that's the mechanistic bit. And ultimately, and I believe, it takes time. And if you do this for a while, you get to a point where you kind of know what's going on around you and you can start playing. And I think a lot of what we do is achieving through play, learning through play. I'm a very big proponent of that. Project-led learning. Go and do something, figure out how to do it as you're going along with it. Sadly, I think a lot of that's lacking from schooling, actually. But you get to a point where you can create, and you can say, okay, I want to achieve this thing. What do I know about that I can sort of pull in? How can I code this? Nowadays, we've got lots and lots and lots of third-party libraries to do things. You know, there's a meme, a joke about Python. It's very rich class libraries that you have with Python dependency stacks, where you know, I need anti-gravity. Okay, import anti-gravity. Whoosh! All of a sudden, I can float because I've got anti-gravity. And the idea of that is it's really simple to pull in really complicated sets of support for things and just use it without you having to develop that. And again, that's something that's changed quite a lot over the past 30 years or so, because with the internet and search and all the people all around the world who are beavering away on code and on tech, and particularly because of open source, which I'm a big fan of, there's lots out there that you can just pull in and start using and playing with and create. And I think creation is an artistic act. So I think that's where I come from in terms of coding and art.
Interesting. So you mentioned about how schoolings are not very in line with your idea of project-based learning.
Yeah.
What do you think? How should then students engage with AI? Because it is not as what should I say? It is free beyond a certain control, because we see a lot of students. We see a lot of students with a lot of, not a lot, but there is existence of negative characters or negative characteristic traits developing in schools, in students, through fight between students, or through any sort of verbal or non-physical conflict. Now, with the access of AI and the ability of what AI can do, how can that be introduced to schools and students to perform and engage around it?
Again, you know, great questions. I think that's a really wide-ranging question there. If I may, I would probably step back again a little bit to try to begin to answer that and say that, firstly, I have a lot of teachers and academics in my family tree, and I'm very aware of their dedication and the challenge of teaching. I'm very supportive of that vocation, and so I'm not in any way denigrating teachers. I think they do a really hard job, an increasingly hard job. However, I think that the curriculum that they are required to teach is not fit for purpose. Mm-hmm. I think that what we are teaching, if I look at sort of GCSE level, say, I have two children who have just been through GCSE, so I'm very close to this. And I think that we are trying to educate children in a manner that dates back to Victorian times. We are trying to educate people for an industrial revolution where they would operate machines. And we don't live in that world. And the world is changing faster and faster and faster and faster. I do what I do pretty much all day, every day, and I can't keep up with it. So I can completely understand that it's a real challenge to maintain a curriculum to educate young people in this fast changing world. It's not a teacher's job to know what's at the cutting edge of technology. And in fact, the teachers nowadays, since the national curriculum was brought in many years ago, they don't get to choose. If they don't teach the curriculum they're given, they're failing teachers. And that's a real problem. So I think we've ended up in a position where basically teachers, so that they're not failing teachers, have to teach to the test. They have to teach what they're told to teach. But what they are being told to teach is not fit for purpose. Now, I volunteer in local schools, so I've been in the room seeing this. I get involved with work placements and work experience and internships, both with local schools and undergraduates, and I take on graduates from local universities. So I'm trying to be involved, and I'm trying to educate myself on the lived experience of this, rather than just coming out with a lot of theoretical nonsense that is my opinion. This is actually what I see. And my very great concern is that even before we get to AI, which feeds into this, the curriculum that is being taught is archaic. It's out of the arc. It's not useful to what we need in business. I can only speak for my little part of the world, which is embedded systems tech, connected devices tech. But I'd speak with many, many business people from smaller and larger business, and they all say the same thing. The young people who come to them have no useful experience and no ability to do the things that they need them to do, which I would effectively characterize as critical thinking. We need people who can do critical thinking, can solve problems, can understand and deconstruct and plan out and work on problems, and work with others and have the soft skills to work in teams and work with methodologies like Agile and know how to commit code and work within projects and use issues. This is what we all do. There are different ways of doing these things, but this is the basics of what we need. And they don't get taught any of that from what I can see. Now, speaking with a friend of mine who is a senior fellow in IBM, his approach is the same. And he says, if we've got some bright kids who come to us and they're motivated and they want to get on, they want to contribute, they want to get into things, we can teach them the specifics of anything we need them to do. That's not the issue. But we do need them to come with some basic stuff, critical thinking, problem solving. And I don't really think you can get that from, sort of looking at a whiteboard or a piece of paper or ticking a multiple choice box. You get that through doing projects. You get that through experiencing what it is to do a project. And I go back to me tapping at my computer in my bedroom in my early teens, trying to figure out why Frogger wasn't working. And that, for me, is a critical missing component of education. So even before we get to AI, we've got a catastrophic situation here for the economy and for young people coming into work. Now, some of that relates to the lack of apprenticeships. Apprenticeships disappeared around about the 80s. I find it very positive that within the Liverpool City region, and indeed within the country, there's now, I think, an understanding from government level on down that we desperately need to get young people into experience of work and work-led projects. And I know there are various schemes, SME engagement schemes and so forth, around and about Liverpool, which I know more about than the rest of the country, to do this. And I think that's great, and I think we need much, much more of this urgently. So having said that, the next bit is, okay, where does AI fit in with this? Well, as I've hopefully outlined, I think we've already got a massive challenge before we start thinking about the next bit. And AI is like all of that stuff on steroids. You know, I'm working with AI every day. We are, I would say, an AI-first business. I'm very there are pros and cons, but overall I'm very, very positive about what AI brings to what we do. However, I'm getting email upon email upon email and message upon message upon message about new models been released today, different one tomorrow, new features into new MCP marketplace in Cursor yesterday, blah, blah, blah. Even within just the world of AI, it's impossible to keep up. So, I can't do that. I'm quite open about that. How do you do that within a course, within a curriculum? How does the teacher, it's not their job to know about these things, it's their job to impart knowledge. How are they enabled to do that? I think that's a real challenge. Now, going back to curriculum and going back to teaching to the test, I think there's been a move to make it easier and cheaper to evaluate how students perform. I think we do need some standardization across the country, but this to me leads to a kind of box-ticking set of exercises, which again does not help with critical thinking. I think it is ultimately more expensive to help young people to develop the skills that they actually need. And schools don't know what to do, really, in my opinion. We don't in business either, mostly. This is a massive time of change. I think AI is probably more disruptive than the internet was at the turn of the century, which is a big statement, I appreciate, and I lived through that. But I think it is. So what do? Now, I go back to my children and the people I speak with, and I think this is changing, but the initial position was, no, you can't use AI. The AI will do the work for you. It's plagiarism, and schools actually went off and invested, still do, in platforms to check the submissions from the students, and if they were flagged up as AI generated, whoosh, you've committed, an offence or whatever. And I get that. It's a really difficult problem. But the counter side of that is that we all use AI in the world. People use it in their personal lives, in their business lives, some to better effect than others, admittedly. But if you're saying to young people, you can't use AI, you're not preparing them for the world. You're damaging their chances. So this is wrong, in my opinion. And I think that's changing, and there is an awareness that within education, young people must be educated to use AI, and it's really difficult. So I'll give you an example, if I may. So my daughter has started at university. She's studying maths. She's in the first year, and I'm trying to help her with some of the more computery side of the maths, because they've thrown her right in at the deep end, and there's a kind of an assumption that in trying to do a maths course, she's also going to be able to learn Python in the background, and SymPy, and NumPy, and the rest of it, which I think is, overly optimistic, quite frankly, and there's a whole other thing here about the way they put the students under pressure. So I'm trying to help her with that, and I talked to her, and we were discussing, she's having to sort of write test programs to exhibit particular kind of mathematical algorithms, and a lot of this is about getting her going with these Python support modules like SymPy, NumPy, SciPy. And I'm saying to her, look, well, I think, if we look at, which we will come on to, if we look at what I do to educate myself about AI, go and ask ChatGPT, because that's a really productive way to learn this stuff. And we had to really think about this, because she has, quite rightly, quite a comprehensive use of AI policy that she must adhere to within her work. And I suppose basically it boils down to, if you're using AI and AI is giving you the answers and you don't understand the answers and that's what you're submitting, then you're going to have a really big problem. But the university does recognize, which is great, that for her to learn things, it's incredibly productive for her to use an AI to learn things. Explain what this bit of code does. What does that mean? Find the documentation for this library function. Boom. And whereas in my world, I'd be Googling around and trying to find the right bit, and I'd be searching through pages, and I'd be like, is that right? No, that's wrong, that's out of date, that's changed, that's new. She just goes, it's not quite this simple, but she just goes, well, tell me about this. And it tells her. And sometimes it's complicated. And I say, hey, tell it you're just learning your first year and not to be so complicated. And it redoes it, and it's much more simple. This is great. This is fantastic. This is incredibly powerful stuff. So it's critical for UK PLC, for our economy, for the success of our young people, that we somehow massively change how we teach. And we arrive at a place where AI is absolutely embedded into, and not in the way that I use embedded, but embedded into the curriculum. But it's all too easy just to throw the full question at the AI, copy out the answer, job done. I have to resist urges to do that myself, because it just, the AI, as you know, Jay, is that we'll come on to what AI means, but when I use AI today, I mean large language models or LLMs, and the whole purpose of the LLM is to appear to be a correct, comprehensive, human-like response, even if it's complete nonsense. And a young person doesn't know what is good and what is bad. Neither does the AI LLM. This is a really big problem too. So, having gone on at length about that, I think that the key thing here is we have to massively change the whole process by which we transfer knowledge to young people. I think that it needs to be much, much more about project-based self-learning and team working and open source and these kinds of things. And I don't know how we're going to do that, quite frankly, but I see apprenticeships and degree apprenticeships as being a really positive step in the right direction.
Interesting. Now that you've gone to this length, I want to understand the agency of humans and AI, to understand the interaction between the two. Because when we say LLMs, when we say AI, the capabilities it possess is a lot.
Yeah, absolutely.
And the agency that human has. I want to understand the interaction between the two agencies and not just prompt engineering. The context that is coming from is to understand that when we are talking about how should youth develop skill set, I just don't want to focus it on learn coding to learn AI.
Yeah.
I think if we understand the agency of what agencies would human possess even when AI
Yeah.
becomes more powerful than this. If we understand the agency, we can understand how should we teach youth, how should we teach everyone, and what should we teach them, so that the engagement of human and AI is clear.
For sure, yeah. These are questions, Jay. These are difficult questions. Again, I don't pretend to have answers to all of this stuff. I'm as interested in exploring this as you are, as I think we all I don't know who will be listening to this, and I don't want to sort of come across as perhaps being patronizing and explaining sort of stuff that people know, but if AI is a slightly sort of cloudy thing to some people, one example I have here is that I went to a great keynote speech on AI in the economy and in the country down at the Digital Catapult in Euston and London. And their keynote speaker had some really, really interesting things to say, and he had some charts, and he was sort of saying, why is it that we never quite get AI working, or we've never been able to do this? Which is a slightly odd opening comment. But his point was that, AI has been around at least since the 50s. The AI is not a new thing. I've been following AI, my entire sort of young adult life. But every few years it means something else. That's the key point. So we've had neural networks, we've had expert systems and expert advisors, we've had all manner of different implementations of this general idea of artificial intelligence. And it's never really taken off. It's always been something that like the techies and the nerds get quite excited about. We get quite excited about. But the general population doesn't really see any value to it. I mean, there's no usable value here. There hasn't been until this kind of breakthrough with large language models. And all of a sudden, people are able to like tap away and talk to an AI LLM, which we're calling AI today, and they get things done and they get answers and things happen in the real world, and they just see the use of this, and it's massive. That's the beginning of where a lot of this disruption comes from for me. But and again, I don't create AI LLMs yet. I'm hoping to teach myself how to train up models. So I'm no expert on this, but my understanding is that basically an LLM is a massive set of weighted numbers. And the training of a model is putting lots and lots and lots of information in to fine-tune the weighting of how these numbers are all connected. Now that's not quite correct, but in a very, very basic way. And so you've just got this kind of big black box, and you train it in certain ways to do certain things. A large language model will tend to be trained to do lots and lots of things, which is why it's incredibly expensive to train one of these things, which is a whole other set of problems. And then when you interact with this yourself, maybe you're typing, so you type a sentence in or some sentences in. And those are tokenized into basically a set of numbers as it goes today. And that goes through this black box, and you get another set of numbers out. So to my mind, that's basically like a directed statistical random walk. And the difference here is that it's so big and so comprehensive, astonishingly, you get this amazing output out of it. Now, again, I know that actually the way these systems are constructed is a lot more complicated than that, but that's how I think of it. And that means, which again, we coming back to the question, is critical here. If I write some computer code, I'm taking decisions, I write that computer code, I'm going to get an output. If I approach something in the same way tomorrow, I'm going to get the same or very similar output tomorrow. That's how it works. That's how it's always worked. If you kind of know what you're doing. Now, if you ask the same question of an AI LLM, you can get different answers out. That's really different. And for a lot of people, that's really scary. Because a key part of what we do here, we may be delivering engine management systems, something that controls braking in a car, something that manages your pacemaker to keep you alive. There can be really serious ramifications to your code not working correctly. So there's a lot of work over many years that's gone into good process to create good code, good tests to ensure it's good code, formal verification of good code. We have a whole body of work to try to ensure that what we do works and is tested and is replicable, and we're not going to have problems down the line or cause people problems. Now, admittedly, when you're trying to run something up on your desktop and it doesn't work, you may be questioning how well we've done that. It's more prevalent in, say, the medical industry and transport, things like this. But, you know, that's a thing. And we're moving into a world where all of that, you know, I ask a simple question twice and I'll get two different answers. How do I ensure code quality in that environment when I'm basically getting a not entirely random, but a not controlled response? And critically, as far as I'm aware, there's a lot of work going on this, but we don't really understand what goes on inside this black box, which you may want to think about the next time you're thinking about how your AI in your automatic vehicle is running and how it's been tested to ensure that it's not going to crash you into a wall. Because I don't think many people know. Other than that, they say, well, we've been driving around for 5 years, it's only crashed a few times, so you're probably okay. But there is no formal verification of that, which is actually critical in a lot of industries. So there's lots of questions about this stuff, lots of concern and worry. The thing that worries me is that I've been trying to educate myself on this for about 6 to 8 months now. And I've been through a process of just trying to figure out what the heck all this is about. You will know lots of acronyms, lots of different tools. Everything's changing like multiple times a day even. You know, how do you know what you should be looking at? There's not enough time in the day to look at this. But to try to, if you've got the time, to try to give you a run through of the process I went through. So I started out using chat models. So a good pal of mine, Max, he introduced me to this Claude large language model from Anthropic. And he said, oh, you know, Claude's nicer than the others. You should chat to Claude. And they don't torture Claude as much as they torture the other AIs. I said, what are you talking about? And it's a semi-joke there, because it's not torture, but they do a lot of negative input into these AIs to train them to do what they want, which, you know, as we edge closer to AGI, that will become an interesting conversation. So anyway, I started chatting to Claude, and he says, oh, can you tell me about this thing? And it goes off and it researches all sorts of things. Can you, I upload a document, can you give me a synopsis of this? I'd like you to you know, create this web page for me. And I was immediately struck by how powerful this was. But for me, now, if I was, say, a marketeer, or if I was doing research, that would be great. And I know various business colleagues who are using specific implementations of AI tooling for exactly this purpose. So if we were to talk later about jobs disappearing, I think there's a significant element of research and research analysis that is going to go away. But for me, I'm sort of creating integrated software hardware products. So it became very frustrating very quickly because I'm sort of uploading a file and it's creating an artifact and I'm downloading an artifact and that's really slow and cumbersome and limited and it's not good. And I thought, well, yeah, there's got to be a better way than doing this. And I then came across the next sort of evolution in my understanding of this stuff was agentic. So I then started, what is this agentic stuff? And this is like blew me away. So again, you know, not wishing to teach anybody to suck eggs here, but I mean, you know, if you haven't had a look at agentic, have a look at agentic. So agentic is basically what it says on the tin. It's using agents. What's an agent? Well, if you think of some kind of command that you might run on your computer, your laptop, your desktop, I don't know if people use the command line. I use the command line a lot. Loads of different tools. You type in a tool, you get it to copy some files, delete files, edit files, move things, do all sorts of stuff, browse the internet. And agentic is where your AI LLM model can make use of those tools. So it suddenly becomes incredibly powerful. And a lot of what we're hearing of right now with some of these sets of tooling like Claudebot people talk about is that the more access you give, I'm just going to say AI instead of AI LLM in future, but that's what I mean. The more access and control you give your AI, because it has no internal conception of good and bad and what it should be doing, what's a terrible thing to do. There are things called guardrails that try to limit this. But again, this is all kind of hoping for the best. If you give your AI the ability to wipe all the files on your computer, then it is possible that it will do that. And, if your computer is still working, you will say, why have you wiped all the files on my computer? And it will say, oh, sorry, yeah, that was a mistake, wasn't it? Then what do you do? And that's not idle speculation on my part. You will know, Jay, that is exactly what has happened to people. Databases have been destroyed, files have been deleted, work has been disappeared. So there's a real tension between I really want to empower my AI to do incredible things with me, for me, to be productive, to create value. How do I manage the risk of that can go wrong? And even though I could say, don't delete files, never delete files, I will switch you off if you delete files, you must not delete files, it can still delete files. And I've had that kind of situation myself. So this is interesting. So I got into Agentic. Maybe we could talk a little bit more about that later, because I think there's a lot of value there. And then I got into specifics of what we call MCPs, which sort of add in different skills, if you like, that AIs can use. And there's lots and lots of work going on in this space. So to come back to it, I think all of those things are an underpinning for what the next generation of software engineers need. They need to know how to do that stuff. I don't see any world in which that's not going to be a core part of the job, from my experience over the past three-quarters of a year. What really worries me, sort of coming back around to it, is that I've been doing this a long time. I've been playing with computers 40 years. So what I like to say to people is, you can imagine just how many mistakes I've made in that long period of time. I've made a lot of mistakes. Sometimes very painful mistakes, sometimes very difficult things to fix. And hopefully I've learned a little bit, and that's experience. And the reason I do things the way I do things now is because I don't want to be in those situations. The reason I try to follow good practice, best practice, is because I know if I do it that way, it's likely to just go horribly wrong. Again, I don't think any of that is present in the way that young people are taught within academia. It's non-existent. And I think that's massively problematic. I think that's where the work experience comes in. But I think this kind of industry experience, work experience from experienced engineers, and I can only really talk from an engineering standpoint because that's me, that needs to be going into the heads of young people from a very early age. And again, we do that through project-led learning. So, I keep coming back to the same thing here. When I work with the AI, and I'll skate over the details at the moment, but I'm basically asking it to do a job for me, or to work with me to do a job. And there's a lot of negativity, quite rightly, about AI slop, quite like the MS slop term, and a lot of dubiosity, shall we say, about vibe coding, quite rightly. It's very easy to come out with absolute crap. And I quite like the term vibe engineering. I prefer to think of myself as a vibe engineer now. So I'm not just going along to the AI and saying, knock up this program to do this thing for me, and then hoping for the best. And it may look good, it may not look good. Who really knows? We don't know. I'm going along and saying, okay, let's follow best practice. We want to use these kinds of ideas. I want you to present me some options for how we might implement a thing to do this thing. I will decide how we should go down that route. Put a plan together that we can work through step by step to put this together. It's critical that you add in tests at each step so that we can make sure that what we're doing here is working and functional, and we can check for regressions because they sadly come in all the way through prompt engineering with AI. I use a lot of continuous integration testing so that whenever there are changes, they get tested and built, and we move forward, and we have an ability to ensure that what we're doing continues to work well against some set of metrics. So I don't quite have the definition of what vibe engineering is yet, but that's what it's going to be about. And I get to, it's not perfect. It's a massive productivity boost, 10 times, 100 times more work I can get done. But there are a different set of problems that I'd encounter as an engineer and within my business. Not least that there is now nobody who knows exactly what all the code is doing, because we didn't write it. And when I have customers coming to me and saying, hey, Alex, how does that thing work? And I'm saying, well, I don't know, actually. It's like, what? But you're supposed to be a professional engineer. That's going to be a very interesting change as well within coding, within the industry. But fundamentally, as I work through these processes, I'm able to do that because of the 40 years of mistakes I've made, and because I like to think I've got a vague idea why I do what I do and how I should be doing this, what best practice is in the industry, what's available, what's good, what's bad. And the key issue then is, if you bring in a junior with no experience and you think they're going to be able to do that through prompting in AI, well, they're not. I very rarely make statements quite so bold as that, but that's the risk. And we're seeing the understanding of that, I think, right now. We know lots of particularly bigger companies were laying off lots of staff because they thought the AI could do it. They could, it could happen, cheaper than it was before. There's an argument about whether the C-suite really thought that, or it was just another way to, give immediate shareholder return or whatever. But it's been happening. In the past few days, IBM have announced that they've had a rethink, and they've significantly increased their intake of junior engineers. Now, I don't know, and I can't speak for them, but my analysis of that is that they have understood that the engineers have to have the knowledge base to drive these tools, and bad things happen when you don't. And so the question then is, if, I know what I know because I've tapped away on my ZX Spectrum because I didn't have another option. If you're a young person coming into the industry today, and you will have perhaps been told at school, at university, you're not allowed to use AI. As soon as you sit in front of a desk, the opposite will be true, and they'll say, get that AI out and start using the AI, because there's a thinking that that's more productive and cheaper. But they've never had, to that point, the ability to learn the experience of how to do these things. So I think of that in terms of a lot of my career, again, when I started, there was no Google. So we used to get data sheets in the post. Things were slow. It was quite nice. Everything was quite slow back then. And then, the internet exploded and Google search engines came along. And a lot of what as an engineer, a lot of what I do is I would say I'm pretty good at searching. I can create a good set of search criteria based on my knowledge. And also critically, I'll get a load of stuff back and I can really easily go, well, that's nonsense. That's never going to work. That's licensing on that's too bad. That is too complicated. That one might do. We'll try those two. And so I can filter for value, for correctness, for whatever the criteria might be based on experience. And in future, I think that migrates. We're seeing it now. That migrates. So we're not going to be searching with Google. We're going to be prompt engineering with the AI. But you still need to be able to filter for quality or by some metrics what the AI is giving you, because it doesn't know. It might be brilliant. When I was getting started with this, I needed a protocol for some communications. I had some criteria for this. It needed to be lightweight and devices communicating. I thought I'll give it a go. So I asked Copilot, I need these things. Can you, go and have a look around, do some research, and tell me, advise me on what the best options would be. And it came out with a number of options. Top option, it explained to me, and it looked absolutely perfect. I thought, wow, I love this. This is great. And then I went to try and find this protocol. I couldn't find it. And I said, can you give me a link to where I get this? And it couldn't find it either. So what? And it had just completely made up the answer. which is, people term hallucination. I really don't like that term hallucination, because the AI doesn't know, truth from hallucination. It's just a random directed walk. Sometimes you get the truth. Most of the time you get something useful. Sometimes you don't. But you have to know or check. You have to be able to evaluate this. And that's where I see the wheels coming off. Because if we throw a load of inexperienced people into creating whatever it might be, particularly computer code and computer systems, and they don't know how to evaluate what they're getting, down the road, you're going to find that stuff has lots of internal issues and problems, and you are going to have a heck of a job trying to untangle that, because nobody knows how it works. So I'm very focused on, I don't know the answers. I mean, how do we deal with that? How do we still, before AI and with AI, I think we still desperately need to enable knowledge transfer between more experienced people in any business enterprise activity, unless we need that pipeline. We need the younger people picking up the knowledge, as I did when I started working in the mid-90s. And it concerns me that there may be a belief that this is all, I don't know if you remember, Jay, I think you probably will, but turn of the century, it was the same. We were talking about internet agents. It wasn't AI, but the entire world had changed. We didn't need to work the way we used to work before. The internet was going to change everything. And we know that has come to be termed the tech bubble, which burst with many problems. And we're in a similar kind of situation now. I'll emphasize that I'm really positive about AI. I'm really positive about the internet. I think most people are. But we did have the tech bubble based on what people thought the internet would change and would enable, which there's a lot of people doing sort of overselling, snake oil, making a few bob, pulling in some investment by just making things up. And there's some of that going on now.
It is very interesting on what you said about how things are changing and how can they potentially change. And there are a lot of issues with trustworthiness of AI, and it is very complicated to sort of understand unless we build a more reliable we build a more reliable process to make the powerful LLMs and AIs more trustworthy. But then looking at what power they possess as of now, considering or hypothetically considering that it will become more and more trustworthy as time passes, then how an individual should look at that in terms of job perspective, because the power it possesses is almost like, because this is what my understanding is from a non-tech background, is AI is or will become sort of a digital assistant who will always try to please you, and that pleasing may come in the form of misinformation or false interpretation or misunderstanding, to be fair on it. Then how do we consider all of this and integrate it in an individual's life? Because non-tech people may also lose their jobs. A lot of creative jobs can be lost in terms of how AI is coming up with images and videos, which is kind of a threat to how even creative fields may affect.
For sure, yeah. So I mean, there's a few points in there, I think, aren't there, to try to take them in order. I must say, I'm not an AI expert. I'm not at all convinced that we're just going to see some sort of endless improvement of the abilities of what we're using today. In the sense that, it comes back to what I said before, we use the term AI, but that has a specific meaning today. When we say AI, we mean almost certainly LLMs, large language models. That's a particular mathematical model, architecture, way of doing things to get certain things done, to get certain answers. We didn't have those 5 or 10 years ago. I have every reason to believe it will be something else in 5 or 10 years. I have no reason to believe, given the history of the development of AI, that in the future, when we talk about AI, we will be talking about LLMs. So I don't think that there's some kind of endless exponential curve of correctness and trustworthiness that we will magically obtain from the current, from incremental improvements on the current technology. Now, I may be wrong about that. I'm not sure about that one. That's my sort of thinking at the minute. It may change. I'm trying to keep an eye on this and figure out what's going on. And so I'm sticking my neck out there. We undoubtedly are seeing right now incredible advancements, very significant advancements in how we can use these LLMs. And I think that as more and more human beings learn more about how we can interact with LLMs, that's going to be hugely powerful as well. But I believe today that we're going to reach a critical point where that's as far as we can go. And I think that we will be looking at other technologies in future. There's a number of people, lots of different opinions, of course, and who am I to say that? I certainly don't work within AI, so my opinion is simply a bystander who is trying to educate themselves. But there are people who are saying that you will never get AGI with the current crop of LLMs. AGI, as we know, is what we would sort of term as sentient artificial intelligence. I leave others to form their own opinions on that. But I don't think this is sort of an endless set of improvements. I think this is a massively disruptive power-up, but it has its own sets of limitations. And I don't see any way today, maybe I just haven't found this yet, but I don't see any way of eliminating the problem that we might term the hallucination problem. The problem that the AI doesn't actually know if what it's telling you is true or not, or good or not, or moral or not, or will hurt people or not. There are attempts to assist with that, as I say, with these guardrails, but inherently it doesn't work like that. So you can, in engineering terms, you can bodge things around that, but at its core, it still is what it is. Now, this brings me back to saying I really strongly believe that when I started out in the mid-90s with embedded systems, I was really lucky because I left university and I went into this job at this company, Arcom. Didn't really understand then, but at that time I was actually surrounded by these amazing engineers, and I just kind of like soaked up all this stuff from them on how I should be doing my job, which was just hugely, in looking back on that, hugely valuable to me. And then, sorry, I've lost my thread of thought there, so I'm going to have to come back to it. What was the question again? Sorry.
So my question was to understand, like, with presumption that AI is sort of a people-pleasing digital agent, and then how will it affect jobs in general, not only just tech job, which already explained on that people in tech will need to understand the functioning of AI through its core to be the best in the market. But also for the non-tech.
Got it. So when I started out with embedded systems, and I was picking up all this stuff, I was learning from all these more experienced engineers. I was a junior engineer, and at that time, I would say that this discipline, this part of the industry, was fairly free form. It was relatively young in terms of what we were able to do, how the technology was advancing. Nobody really had, set in stone practices for how you did embedded systems. It's all a bit of a black art. And that could be quite challenging, but it also made it lots of fun. because we were kind of just figuring things out as we went along, which is how I feel about AI today, and it's why I find AI really interesting. Now, we used to term it, or the other engineers used to term it, this is all a bit like the Wild West, because we're going across the frontier's land here, and we're ploughing new ground, and we're figuring out new ways of doing things. And over the past 20 or 30 years, that has become much more established. And so we've got sets of best practices. We've got university courses in how to do embedded engineering. And we've got sets of this is how you do these things. You can argue about how good they are, how relevant they are, but we have those things in place. But they didn't used to be in place. They have come about over quite a lot of time, and over quite a lot of people getting things wrong and trying to work out how to be better, which I think is essentially the process of doing tech. And I think that's exactly where we are with AI now. So we've got these amazing tools. We've got people trying to figure out how to use them. We've got lots of things going wrong. We've got lots of AI slop. But what I think we're going to see out of this, and what we really need to see out of this, is a new set of best practice. And I will, again, do a bit of future gazing and say, I think we're going to have something which may be called vibe engineering, which will be a set of best engineering practice for working with AI LLM tools to achieve goals. And that's going to be really quite different from how we have done our engineering in the past, because there are different abilities that we get from working with LLMs, and there are different constraints when we do. The big one being that we can't actually trust what it tells us. To go into that a little bit, there's a big movement within software engineering to do with testing. We talk about unit testing. So again, I'm sure lots of people know all about this, more than me about this, but you write a set of code, you structure it well, you modularize it, you abstract it, you make it reusable, and then you have lots of tests to make sure all the bits of your code work as you think they should and handle errors as you think they should, and that gives you a level of confidence that your code is good code. And then you can take those tests and you can put them into an automated system, and I think we're going to talk about automation a little bit, but you can then run those tests in an automatic fashion. So every time your software team comes along and makes some changes, you can rerun all your tests, and if they all pass, well, that's the level of confidence things are good. And if you've got issues with things breaking, oh great, I can see that they broke. And if things break and you don't have tests for them, you can add in some new tests. So this is regression testing. This is to make sure that as you make changes, you don't break stuff. And that is viewed as keeping your code quality high. And that feeds into another term, code coverage, which is where you say, okay, I've got all this code doing all these things, and in here, there's a percentage of code that I'm testing, and there's going to be some code that I may not be testing. So I'm not entirely sure if that works or not. And people talk about the kind of level of code coverage that you need to have confidence in the code that you're producing. And, we're a small business. We have a slightly different approach to this than maybe a big multinational might have. But these are the concepts behind code quality, code hygiene and code quality. So you'll have this is called continuous integration, or CI, where you make changes and it kicks off builds and lots of tests happen and you get reports. Now, for me, I'm not against that. I think that's a good idea. But the way I approach it is that we have a certain amount of resource that we can throw at a project, and we need to deliver it in a certain amount of time, and the customer is willing to pay a certain amount of money. And we've got to kind of walk a line between, okay, we do need to deliver a level of reliability and quality with our code as professionals, and we do need to be testing things. It's got to work. But if we spend lots and lots and lots of time creating lots and lots and lots of tests, is that a good thing? Well, in isolation, yeah. But if that's taken out of the resource of delivering the project, how does that affect timescales and cost? And in the real world, we need to be thinking about this. going back in time, you talk about Bill Gates, you talk about Microsoft, and there's an argument that Microsoft and Windows were successful because they adopted a just good enough strategy. They didn't try to make the perfect operating system. They didn't try to make it, absolutely bulletproof. They got to a point that people would not throw it away and shipped it. And that's why there's an industry joke that you never start anything before it's version 3. Again, I'm not against these, but I think they have to be weighed up in terms of where we put resource and how we cost projects out. And a key thing for me has always been that I believe, others may disagree, but I believe that an experienced engineer will tend to anticipate sets of problems, code for sets of problems, handle sets of problems, and given that they're doing that, and that's part of the job, it's kind of a waste of time for them to be also doing a load of tests for those problems. Unless you're like a really big company and you need to do that stuff. It's always useful for regression testing, but it's not inherently necessarily something you need to be doing. I think you might put more emphasis on structured programming and peer review of your programming and good source control management so that you can see where things are changing. But that's just my opinion. And that has very significantly changed because as I got going with agentic programming, and I'm sort of going in and saying, okay, I want you to develop this computer program for me or add a feature to this piece of computer code for me. It can go very, very well, and it can go very, very badly. You never quite know. It's quite terrifying. It's a very different way of interacting when you create computer code, in my opinion. And it becomes critical. These are my thoughts from my learning over the past, fraction of a year, whatever. Mm-hmm. It becomes critical that you can lockstep, get to a point where you're happy with something, lock that down, get to the next point, lock that down, get to the next point, lock that down. So firstly, source control management is critical. Typically, as I'm engaging to create code, I'm asking the tooling or asking the LLM, the agentic LLM, to use tools on my computer. Now, I use something called Git, which is for source control. GitHub is one of the sort of commercial places that host lots of Git repositories. People will know that. There are command line tools that you can use to interact with GitHub repositories. One of them is GH for GitHub, and you can use that to do all sorts of things. You can create issues, you can trigger workflows and continuous integration tests. It's kind of a Swiss Army knife tool. So I have my agentic LLM using the GH tool to create commits and commit messages of the work it's done, to commit the changes it's made, which then trigger CI builds, and we can see if they work or not, because I have testing in those CI builds, and I then ask the LLM to go and look at the logs of the builds and work out why they failed and fix it. This is critical to me. In engineering terms, I think of this, back a long, long time ago when I was doing engineering, we had this thing called a PID loop, and that was to do with control systems. And in essence, it's a long time ago, but it's something like you have an input into a system, the system does stuff, and you get an output from the system. Think about like a braking characteristic in your car, you're trying to brake. Now, that output might not be what you want, because the system's kind of doing its own thing in here. So what you do is you feed back the output into the input, and you kind of munge them together somehow to modify what's going on as the input to the system, and you sort of keep doing that until you get the output you want. And that's what I'm talking about here. I think of our interactions today with AI. When we're doing vibe coding, I think of that as a kind of undirected, suck it and see and hope for the best process. And we don't know, we have really very little idea how fit for purpose that output is. And that's where the AI slop criticisms are coming in. And I think what we're going to see, and what I do now, what I would like to term vibe engineering, is we check the output. We get the AI to look at what it did, test what it did, evaluate what it did, and feed that back into the next iteration of the process. And through that, I mean, maybe that actually does come back to one of your earlier questions, because we're talking about how do we sort of trust what we're getting more. I mean, I said we couldn't really. I was talking about the internal model of the LLM. But actually, that's perhaps not entirely true, because this is what I'm doing to reduce risk with what we get out of the LLM. So I'm committing changes to code very, very frequently. The AI is generating all the commit messages with all the work it's done, why it's done, what's going on, very comprehensive stuff. Many will argue overly comprehensive. And we get to a point, where something breaks. And I go, hey, go back through the commit history, because this used to work. So you've done something to break this. Figure out what you've done and fix it, please. And more often than not, it will. So you've got to have that history of change, and you've got to have that control. And you don't get that just using the LLM. You get that by using that in an agentic way with other tools, which you have to know about as an engineer. If you don't know if you don't know what Git is about, if you don't know what source control and SCM is about, you're not going to be able to use that well. And you need to get the quality out. So it comes back to what I was saying about knowledge transfer and experience. Then, as a part of what I've just been explaining, it then becomes critical to have those tests. And it's very easy to get the AI to create a load of tests. You want to have a look at it. You want to check that they're doing what you think they're doing. Again, all of this, you really need oversight. Oversight is another critical thing. But you can easily create lots and lots of tests. And you can easily put those into a CI script that runs on every change. And you can easily tell the AI, that stuff's not working, figure out why. So you're closing the loop. And if there's anything that I would say today, it's that is the critical bit that we all need to be getting on top of for, I'll call vibe engineering as a foundation for best practice for working with these new tools. And it's not a panacea. It's not the answer. It's not going to make everything perfect. Nothing is ever perfect. And legacy human written code, we know often doesn't work terribly well. So, but it gives an element of control, and it gives an element of being able to go back through the history and see what the heck's gone on.
So you mentioned about automation, and there are a lot of terms that are sort of popping up nowadays whenever we go through any sort of AI thing. Three major terms that sort of pop up every now and then, that is AI in itself, LLMs, then machine learning and automation. So what are those? And like, how do we understand the differentiation between them?
So it's a good job that there are no university lecturers around, because they would no doubt rap my knuckles, because I don't know the correct interpretation of these things, because I just sort of pick things up as I go along. I certainly tell you my view. So these AI LLM models, we sort of talked at length about what goes on inside those. So I think we can talk about it. It's a black box. It does incredibly clever stuff. It's trained on huge amounts of data, and there's lots of different ones trained on different kinds of data, which are therefore good at different kinds of things. And we're going to see more diversification of that in the future, I think. I'd like to talk a little bit about LLMs and indeed SLMs as well, so I might come back to that. But in terms of machine learning, I'll give you another example. So the things we've talked about, me on a laptop talking to Claude or Chat or Gemini, whatever it might be. And I might have Agentic, where it's enabled to run tools on my system. Now, there's a different way of doing things for a different use case, different set of purposes. We develop all these embedded devices. Particular sets of embedded devices would be sensor devices. So, we might have battery-powered, radio-connected sensors doing something all over the place. One of the things that we're doing at the minute is quite an innovative gas sensor. And so you can put this in a room or in a building or outside or wherever you want, and the technology, the sensor hardware, the chips, can detect a range of different gas profiles. Now, by that, I don't mean that they know a particular gas, but they know particular sort of chemical compounds. They can see if they're present or not. Now, you could theoretically go off, and a human being could write a program to say, if you see these kinds of levels of this and those kinds of levels of that and this kind of level, then it might be this kind of thing, so flag up that we could see this kind of thing. Okay, that's how we would do things. But it's getting really exciting now because there's another way of doing this with machine learning. And what that is where I come along as an engineer, or the team comes along, and we train our own little model. Well, it doesn't have to be little, but relatively speaking, for what we do with embedded systems, it's constrained devices, so smaller models, not a massive supercomputer GPU type of thing. And we can train a model, with a set of inputs. If you get these inputs, then somebody's vaping in the school toilets, or your forklift truck driver might have been on the cannabis. And so we can put all of this information to train our model, this is machine learning, and take that and put that on an embedded device, and it can then detect this stuff, which is really, really interesting. And that kind of approach can be used, you can imagine how many different arenas that can be used in. So I'm talking about gas sensing. We talked to people about, detecting smells of rodent droppings in houses. We talked about, cable breakdown before fires break out. The list goes on. And then there's the other kinds of things that are more in the public domain, like face tracking, who is who around the airport, gait analysis, can you see who somebody is as they're walking along? All of this type of stuff. So that's more, for me, machine learning. And one of the big light bulb moments I had some years ago was that I thought you might think of LLMs as like these massive, lots of power, sucking up the energy output of a country, all the water's disappearing to cool these things, all this stuff. There's a bit more to it because it can be hugely expensive, energy consumptive to train models. But when you've trained a model, it doesn't have to be that expensive to run a model. So you can get a good model, well trained, and put it on quite a constrained, low-cost embedded system and do some of these amazing new things. And that's quite an asynchronous kind of thing. That's not something I would have thought. There's some cool videos on YouTube with somebody who has trained a model to do gesture detection. It's running on a little ESP32 chip, and it's like basic. I mean, it's very cool stuff. It's very complicated, but it's like low end, $5 stuff, and you can do gesture detection with AI on this. Like, wow, So once I realized that, I thought, okay, there's a very interesting thing going on here with how we train models to do really new and innovative things, but without needing really expensive hardware and without necessarily needing really, really complicated, mathematical human programming to be able to do it. It's a whole set of things that we really just couldn't do before. So I would say that for me is machine learning. And then automation you can look at in different ways, and I'll be quick on that because I think I've talked about much of that, which is that in general use, automation would be, I write some code, how do I manage that code? So continuous integration is automation. CI, continuous integration. Some people, the braver people, are trying to do continuous deployment. So basically you make some changes to your code, it automatically builds automation, it automatically deploys to your devices, automation. There's a distinct possibility that if and when we get to the point we can trust AI well enough, we can have automatic updates to all sorts of devices all over the place. Of course, that can go horrendously badly wrong. If you send an update out to an embedded device in the field, it can stop working. Then what do you do? One of the great stories is a lot of these Airbnbs. There's a smart lock that people were putting on their Airbnbs so that people could go along when they'd go for their night or whatever, and then the code would be changed, it'd be remotely changed, it was internet connected, remotely changed. Great stuff. Unfortunately, the vendor of that smart lock pushed out a firmware update, and they pushed out the wrong one, and they bricked all the locks. Now, you can imagine how upsetting that would be for the owners of the Airbnbs, and you can imagine how, I mean, I don't actually know what happened to the business, but for me, that would be something that would finish a business. So a lot of risk with this stuff. But again, this is all about process, testing and process, which is why it becomes so important. So automation in that sense, I think we can also look at automation in the sense of what I was talking about with agentic tool use. So, I mean, seriously, to be more concrete about things, lots of students, I think, have access to Copilot through using Visual Studio for development. I think there's free layers and things like that. I mean, I've used all of these a little bit, but I'm not experienced enough. I don't have time in my day to have a good knowledge base about any of these things. Copilot's out there. Google Gemini, I like very much. I use that for image generation. Nano Banana works very well for me. And again, coming back to your point about creatives, I couldn't design my way out of a paper bag. I often need icons and things for work that I'm doing, or I need a little banner for a web page or something. It would that's a difficult thing for me to do. It's not really core to what I'm getting on with, but it's valuable for the business or for the product, or to demo something. I don't really want to go out and pay somebody to do that. I might use some stock imagery. Now I just ask Gemini to create something for me, and boom, it's done. It's I feel for people, but people are going to be very seriously impacted, or are being, by this, I'm sure. I was speaking to a gentleman here in the club the other day who has many years of experience in the industry, and he was saying a similar thing from his perspective to what I've been saying today, that you kind of need to know how the process works to get the best out of this. So I think that that there's still a need here, but we're not going to need people just to kind of throw some stuff out quickly, because Gemini will do that for us. So then, in terms of agentic, there's lots of options. There's Claude CLI, and I think ChatGPT has them as well. These seem to be more command line tools that you drive on the command line, sort of non-graphical, not really graphical. And it's odd for me because I'm generally mostly a command line programmer because I'm an old man now. And oddly, I don't like using them, which I find quite strange, because you would think that I would. You'd think that I would gravitate towards that. I would have. I don't quite know why that is, but I find the other way of doing this everyone knows about is IDEs, integrated development environments, where they bring a lot of kind of coding and debugging facilities together into a user interface. And what I've ended up working with mostly is Cursor. Again, there are other agentic UIs out there. I'm not on commission, but it works for me. And I don't have enough time to seriously do a deep dive into something else. So until such time as Cursor isn't doing what I need it to do, I'm probably going to stick with Cursor. What I like about Cursor is that the back end, so Cursor is sort of a front end and extra skills or facilities provided by the Cursor company, which sit on top of, you get to choose which back-end LLM you want to be working with. So I have it on auto a lot of the time, but I can specifically choose to work with Claude or Chat or the Chinese ones like Qwen, or I can run my own stuff locally on my own GPU with a Llama if I fancy. And I do some of this because sometimes, so there's a different speed and a different cost in tokens and money to using a more complex LLM. So I'm tending to use the simpler, faster LLMs to do the jobs they can do. Every now and again, it gets a bit out of its depth. And again, this is me having to determine when this is, when it's going off the rails. And then I've learnt I need to go, okay, actually we're going to go over to a more complex, deep thinking LLM. We're going to reapproach this. Generally that will get me through the problems that I'm seeing. But I need to be able to determine when that's going to be. At the moment, that may well change. So that's quite an important part of this. And the fact that I don't care, I don't have to have a load of different accounts. I don't have to worry about that. I can just switch as I need to, is really, really good for me. And Cursor is basically going off, and it will search through all the files on the file system. It will grep for this stuff. It will commit everything into my Git repositories. It will create tests for me. It's astonishing, And even with that, there's more. So what's really exciting is that in my world, we do lots of coding. We do lots of open source. So a great deal of what we're doing is pulling in third-party components, customizing things, gluing things together. And an enormous amount of what we do is debugging. We put code onto new pieces of hardware. So we have to get that hardware going, add support for new devices that are on the hardware, radars and sensors and the gas sensors I talked about, you name it. And things don't work because that's how the world is. You do stuff, it doesn't work. And you're sitting there saying, okay, well, how do I get this going? So I've literally now, we've got a hardware lab down in the south of London. And I was over in Brazil last year. So I was staying over there just outside Sao Paulo. So I was on my laptop and I had a VPN into the hardware lab in London. And my AI cursor was connecting into our hardware boards that I was working with. It was doing this, not me. So it was using SSH to make connections, to interrogate what was going on in the hardware, to run code and build code and copy code across and run that code on the hardware and look at the output logs where things were going wrong and evaluate what it needed to change. And I'm just gently keeping it on track. Wow. Now, the way that would have happened before, I would do all of that by hand. I could script things up or whatever, but this is hugely time-consuming. And to have an automated debugging process like that on real hardware is astonishing. And I can do that anywhere in the world, And that really excites me. That really excites me for the future of where this stuff is going to go. So I think that we make a mistake if we think this is just about AI slop websites or writing an AI book. Which I have, by the way, if you want to. It's not very good, but it's on Amazon. If you want to read my AI book, I'll find it for you later. But okay. It was AI written. My friends have read it. They say it's not terrible. That's interesting in itself, actually, because the AI. I asked the AI to develop a book for me that would be interesting to commercially. To give me options for plot narratives. I wanted a hard science fiction book, and I wanted this and I wanted that, and it gave me some ideas. And we iterated through this, and I said, okay, how do I publish this? And I knew nothing about publishing books. And it took me through the whole process. It told me that Amazon KDP exists for self-publishing, how to set it up, how to do it, etc., etc. So again, there's much more to this that we can do in the real world, leveraging an AI LLM with tooling, agentic or automation, whatever we might want to call it, than just what I think mostly people are talking about, which is like writing a bit of code for a website. So that's a lot of what excites me about this.
Interesting. So at the end, I just want to know what was your experience of this podcast, and do you have any questions for me at the end?
All I would say is thank you very much for inviting me along, Jay. I know I've talked at length, but I hope some of that was interesting. It's from the heart. I'm really very much learning here, as I don't have the answers. That's as I said about when I started I feel like I'm starting my career again. I mean, I'm not. I'm an old man now, but the exciting bit is this can go all sorts of places. People are going to be able to do all sorts of things. There's lots of risk. There's lots of negatives. There's lots of issues. But we will get on top of those because that's what we do. We solve problems. And it's going to enable us to do a whole set of things that we couldn't do before. So I'm looking forward to that.
Do you have any questions for me?
I don't, Jay.
Okay.
Okay.
But thank you so much for doing this.
Not at all.